I'm glad. I'm glad I helped someone.
Like, they're hard to get through when you're listening to, like, Elise's comments and everything.
Right.
But if you can boil it down to the notes part, it's really helpful, actually.
You know, and it's really not a bad idea. I mean, you can always skip through, well, you don't know how long that lasts, I guess.
No, I was tapping through so I didn't hear Elise anymore. That's how I knew when class started.
That's funny. Okay, let's get started. So yesterday was being a blonde, so we need to go back to the problem that I was being a blonde on. And here's why I was being a blonde. How dare they make us think. So in the probability interactivity your group did last Friday? Yeah. In the probability interactivity your group did last Friday, in our two-way table, we just had totals. So like count. So like out of 350 people or out of this. In our last example before this one, I believe it was 178 people. Yeah. So we were doing totals, we weren't doing percentages. So first things first is our first table with percentages, not totals. So we don't actually know when we read through that scenario how many apartment residents there are. All we know is that 40% of them read USA Today, 25% read New York Times, and 5% read both. So I scribbled all over my notes. So I'm going to have to do my problem on a separate sheet of paper. Hopefully you're not the same, but you probably are because I scribbled your life too. Okay, so they want us to make a two-way table, but there's no reason we can't make a Venn diagram first. So I'm actually going to do part B first. If I get to choose, I choose a Venn diagram. I just think the bubbles are easier to read. You can just see the overlaps and life just gets easier. Okay, so here's my box. Here's my circles. I'm going to do one for New York Times. And I'm going to do one for the USA Today.
I have a question.
Yes, dear.
Are we always supposed to do the box around the Venn diagram?
Yeah, it shows the total. So, like, the people who don't participate are going to go in this little, like, bottom corner.
Like the non-responsive.
Yes, or, like, the people who apparently don't read papers.
Yeah.
Okay, so right now, we know that 40% read the New York Times. But I don't actually want to put 0.40 in my circle. What do I want to actually put in my circle?
40%.
But I don't want to put 40.
Is it out of 100 people?
We don't know that. We weren't told how many residents there are. That's the problem.
4 10.
Okay, so why don't I just fill in the blanks for you? I know the overlap between the two, and I moved my circles too tiny, so I can't put the overlap number. But I know the overlap is 5%. So I'm just going to write that in another color as just a 5. Because if we have to keep changing everything to percentages, that might be a little confusing. So I'm just going to call that 5 or 5%. Either way is fine.
So would it be like 35%?
Yes, and so because we know the total New York Times little circle needs to add up to 40, 35 plus 5 is 40. So it needs to be 35%, or if you just want to put 35, you can.
So we can make it so that it's basically like a sample of 100?
Yes, that way to make it a little easier for us to think through, yes. But is that a bad idea when we don't actually know how many residents? I don't know. It depends on if you're going to remember that or not.
New York Times in general than the USA.
Um,
Like on the last one, there were more boys than there were girls. The percentages could be the same, but there's still more boys in general than there were girls. So if you were to just give the numbers, then it would be proportionate.
right. But we weren't given numbers. So can we just guess how many people there are? So that's why, so he's saying, like, so this is kind of making it all add up to 100 if we've met as the 35, the 20, and the 5, which is fine. It's just, again, the percentage is what's correct. We don't know the percentage of how many people. So, I don't know. I see your argument. I don't know. As long as you're keeping it straight in your head, I don't really think it matters. Okay, so, but both bubbles add up to what?
100?
No. So we had 35 plus the 5 overlap plus the 20. So it adds up to 60. So how many people aren't reading anything?
40.
So I'm going to put a 40% down here in the corner because they aren't reading the paper. Or you can do that as 40. And now life seems a little easier. So maybe I can go back to part A and make a table now. Because I'm really just the same information from the Venn diagrams is going to be used in the table. I got confused with the table yesterday. I was trying to overthink my life. So I'm going to make...
No, the overthinker made you overthink your life.
No, I really overthought my life. And then what's really annoying, and I almost posted on Google Classroom, and then I thought y'all would look at it, and then what joy would I have in telling you the things I do actually know in life? This exact one was in your textbook. Okay, so in this column, I'm going to have read New York Times, yes, no, total. But across the top, I'm still going to have a yes, no. But it's for whether or not they read the Reads USA Today.
That's really weird, yeah. I don't like that.
So this is how your book did it, which kind of makes sense. So I don't think it's pretty, but it kind of makes sense. It makes sense that we have, and then we need a total over here too. So we're wanting to compare not just New York Times versus Today, but we're also going to compare, do you read it, yes or no, versus do you read this one, yes or no. So that's their logic as to why it looks this funky. And so yesterday, I knew we were completely off because you and I both know it needs to add up to 100% at the end. So if we're not adding up to the 100%, then something has gone terribly wrong. And so yesterday we were adding up to 200, so clearly something had gone terribly wrong. So the people who read the New York Times and read the USA Today, that's that overlap, it's going to be that 5%. And then people who do not read the read New York Times, yes. Reads USA Today, no. So that's that 35%.
Wait, is that supposed to be in 55?
No, I was doing if you wanted the percentage or just the whole count.
Gotcha.
And the way I was doing it double in the Venn diagram. Okay, so reads New York Times, yes. Reads USA Today, no. So that's up to 35%, which we know that total is 40%. But again, if you're wanting to do the whole number counts the way Jackson was suggesting and make that a 35 and that a 40 and it adds up to 100, it's still percentages in his mind, I pray. He's just not writing the percent sign and overthinking things.
I think you know what it really is.
Reads USA Today and reads New York Times. So they read USA Today, yes. They don't read the New York Times, so that's that 20%. And this adds up to 25%. And then don't read either. We already figured out that was 40. 20 plus 40 is 60.
Goes that up to 200%? No. Yeah, that's up to 100%.
Right. So if we add 20 plus 40, we get 60. So 40 plus 60 is 100. So it's worked out in this column. Now we've just got to check this row. 35 plus 40 is 75. 75 and 25 is 100. So we are correct. So again, no matter how we add it, if we added the 25 and the 75, that's 100. Or the 40 and the 60, that's 100. But regardless, that bottom right, for our totals, we're getting 100. So I don't know why we were overthinking things.
Because I added 40, 60, and the total.
Yeah, I didn't even think to deal with the overlap yesterday. Like, I don't know what on earth was going on with my brain. Terrible thing. Terrible things. Okay, so we've made the two-way table. We've constructed a Venn diagram. And now we need to actually do some probability. Lo and behold, we want the probability that a person reads at least one of the two papers.
It's really unfair to assume that you read one of two newspapers.
So with that, be like 60, because there's 40% that don't read either.
Okay, so probability of reads at least one of two papers. The easiest way to do it is the way Kenzie did it. If she can tell me what she used, I'll give her a point for it. What vocab term? And you can have a point for it. So she said the easiest way to figure out the probability of people who read at least one of the two papers is just to do 1 minus the people who don't read any. So she said it was 1 minus 40, which is how she got her 60%, which is great. Now, if you're like me and I wasn't reading it like that, and I should have, that was much smarter than the way I'm going to do. But I was thinking probability of New York Times plus probability of USA Today. So I did probability of New York Times was 40 total, plus the probability of USA Today was 25 total, and then I had to subtract out the overlap. And that's how I got 60. But again, I'm making my life way too complicated. It would be so much easier to do it her way. And then part D, we automatically know the answer to, because it says the probability that they read, they don't read either paper. And that thankfully we already figured that out. And that's one perk of the Venn diagram, is that it's easier to see 40% didn't read anything. Okay, are there any questions about this now? Okay, well, I'm going to leave that 'cause still got people copying. Today is the day we finally get to the part you've been trying to make happen all along. It's called conditional probability. And it's like, if this, then this. So you're given something. So they normally put the word given in it. So if it has the word given, it does change things. Okay, so on the next thing. Is she still writing? No. Cody, take it from me. You want it? So the deal with conditional probability is that one event is already known to have happened. So yesterday, someone, I'm pretty sure it was Batman, asked if, like, we know they're male. Back to this question. Is male and has pierced ears. Like, so you know they're male and you know they have pierced ears. Well, no, it doesn't say for sure we know they're male, whereas today the wording implies that. They tell us specifically, like, given male, then what's the probability that that male has pierced ears? So they've got to have the word given, and I don't know why they wrote the formula twice, other than to say it works either way. So you can be given male, what's the probability that I have pierced ears, or given I have pierced ears, what's the probability I'm a male? It can go either way. And then, of course, there's a fancy formula for it, which if you're a formula person, maybe you want to learn this. I think it's on your formula sheet, but I've never really used it because it just kind of makes natural sense, and I think you've already kind of made natural sense before. Like when you were trying to figure out probability of, so given A has happened. So this one has happened. The second letter has happened.
It's like an if A, then B.
Yes. So maybe probability pierced ear, given male. Well, you would tell me you want the overlap of male and ear divided by the probability. For sure you knew they were male. But that makes natural sense. We know for sure they're male, so now instead of using the total of boys and girls, we're just using boys. And then we want to know if they have their ear pierced. Well, we're only concerned about the ear pierced boys, so it makes sense why the numerator is specifically the ear pierced boys. I think it intuitively makes sense, but again, if you're a formula person, maybe you need to learn the formula.
Okay, my thing about all of this, right?
Right.
Is they already gave us the total number of people they asked about that. And they gave
Yes.
us the total number of boys with pierced ears.
Yes, they've already given us all the
Did we
things.
not just do the math to find out that probability?
I think your probability is going to be too high. So if you did the total of everybody, so back to that problem. So we're saying specifically we know they're a male. So we're saying specifically they're one of the 90. They're not out of the 178. We've lowered our sample size. They're specifically one of the 90. And we know for sure they have, well, we want to know about the pierced ears people. What's the likelihood of that? So 19 out of 90.
What I'm saying is, it says, suppose we choose a student from the classroom at random, So at random, it can assume that it means of the total 107.
Yes, and every other time it will be that, unless you see that key phrase, like given something else has already happened. Like for some reason we already know that the one person we drew is a boy. What's the probability that the one boy, which we've already drawn, has pierced ears?
Got it.
So an and isn't. Wait,
So with an and or an or, we don't know either. Like we haven't selected yet. But right now they're saying like we've selected, we have this person in our hand. What's the probability? We know he's a boy. What's the probability that he has pierced ears?
okay.
So something's already happened. In all the other cases, we have nothing's happened yet.
Does that change any of the calculations that we do? Or-
That's what I was saying. It makes it slightly easier because instead of saying out of the total population, since we know specifically it's a boy, we only have to use boys. So forget those 88 girls. Our denominator only has to be 90. But you kind of already got that because you already answered questions with this kind of probability on that interactivity. And your group did great at it. So it's more intuitive than you think. Okay, so it says use the data from the previous two-way table to calculate the following conditional probability. So Ismail, given he has pierced ears. So we know for sure he has pierced ears. So how many people for sure have pierced ears? We got to go back to our other table. So for sure, 103 people have pierced ears. So in our denominator, since we know they have pierced ears, we're going to put 103. And in the numerator, we want the overlap. They got to be male, and they've got to have pierced ears. So it'd be 19 out of 103. And
You
if
don't
we,
want us to actually do the math, right? You just want us to leave it like that?
yeah, you can leave it like this. If you want to give it a percentage, because you know in life they're normally on a percentage, that's fine. They're going to give you your points if it's like this.
But they're going to specify if they want to specifically want a percentage.
They would definitely specify. And plus, if it's multiple choice, you would see from the answer choices what they were doing. If this fraction could be reduced, we would reduce it, but I don't think we can. Okay, but now things have changed. So it looks like the same words, but they're in a different order. So we want to know the probability he has pierced ears given is male. So we know for sure that he's male. And there are how many males?
90.
And then, again, it's still the probability of pierced ear and male, so it's still 19. So it's 19 out of 90. Are there any questions about why A and B are different?
No, I understand this, actually.
So in this one, we were told specifically he has pierced ears, whereas this one, we were specifically told he is male. So it depends on who the given is by. But again, they might not actually put given. They might leave it in that notation. So the second thing is understood to be the given. Okay, now back to our apartment complex that we just did. Cody has my info, so you'll have to tell me the answers. I literally don't know. Probability that a randomly selected resident in the apartment complex who reads USA Today. So for sure they read USA Today. Also reads the New York Times. So we know for sure they read the USA Today. What's the percentage of people? Yes. And then also reads New York Times would mean the overlap. So how many people read both?
5%.
So I need to Jackson would probably argue, and he'd be right, that we need to actually solve this one out. So I'm, in my mind, moving my decimal over 2, so it's 5 over 25, so 1/5. But if you already typed it in your calculator and went straight to 20%, that's fine. I'm trying to overcomplicate my life. I like math.
But for the sake of like just solving the problem, we could put 0.05 over 0.25 equals 20%.
Yeah.
Right?
Yeah. Now, you could be lazy and just go straight to the 20%, but there's always this, what if your answer's wrong? If this is a free response, are they more likely to at least give you a P if you have an answer from the two-way table in your numerator and denominator? Okay, so our next one, she's not here to read. You like read, yes.
Starting where?
Oh, I didn't know that meant like you would read. Oh, I thought you were nodding that she wasn't here. Oh, I misunderstood entirely, Mackenzie. Oh, that was terrible. Go ahead, Jackson. Kenzie, I'll make you read the next one.
Students
read
in
today.
the University of New Harmony received 10,000 course grades last semester. The two-way table below breaks down these grades by which school of the university taught the course. The schools are liberal arts, engineering, and physical sciences, and health and human services.
Okay, so it wants us to read the next thing.
Okay. Consider two events. E, the grade comes from engineering and physical sciences course. L, the grade is C or below. Answer the following questions.
So find the probability of L, which means probability that the grade is C or below. So what is the probability of L?
Do we have to find?
So it would be the final column, you add them all up and you divide it by 10,000.
Okay, because we know there were 10,000 students. So we would add the 2268 plus the 800 plus the 588, and that makes sense because those were the C's or below for each of the said departments. Okay, and what do you end up getting for the numerator?
3,626.
Perfect.
Right?
Yes, you can have a point.
We need to have a sheet out.
It's in the top drawer.
I got filled out already.
Yeah, I mean, I did it in my head, so that's probably why I messed up.
Yeah, I got
56, 36, 56. That's what okay, perfect.
Total C.
You can have a point too.
That's not worth the point.
Wait,
Oh, yes, it is. Everything.
Oh, it's totally worth a point.
Everything's worth a point. Everything's worth a point.
Okay, but seriously.
Oh, I did 58, not 588.
Yeah. I knew, yeah, but so that one's pretty easy. Now for number 2, we want to find the probability of E given L. So we know for sure their grade is a C or below. What is the probability that they came from an engineering and physical science course?
Of course. So for the first one, you would do,
800, right?
yeah, I think 800 over the 3,606.
Yes,
Good.
that's it.
You could reduce
So
it,
yeah. I mean, we probably would want to just give the percentage on this one since it is a reducible fraction. Heck, we probably want to give a percentage on the last one, but hey, they should be happy we.
The second one's a little simpler.
Okay, but are there any questions about that? We're still doing the probability. So we're given failures, so we've totaled all the failures. That's why failures is in the denominator. We know for sure they have a C or below, not failure. They have a C or below. And then we want to know how many of those are in the English and science. So English and physical science, it was 800. Is there anyone who doesn't understand that one? Okay, well now we know for sure they're from the engineering and physical sciences. Goodness gracious. It's not English, it's engineering. We know for sure they're from engineering and physical sciences. We want to know the probability that they have a C or below. So the numerator is still 800 because the overlap is still 800 between C or below and English and engineering and physical sciences. Lord Jesus, help me. But the denominator has changed. What number should be in the denominator?
1,600. Am I right?
Yes. So, which is going to be 50%. And why has it changed to that? What numbers did you add up?
The total number of students in that course.
Yeah, so you added the 368 plus the 432 plus the 800 to get the 1600. Yes, of course it is. Okay, are there any questions about number 2? It said interpret in terms of these contexts, but I feel like we've done that out loud. But on the actual text, you want to add something like, meaning, given a student is from the engineering and physical sciences department. So we know for sure that the kid is taking a class from this department because it told us given E. So I've explained what given E means. In fact, I worded it my own way. It would have been way easier to just say meaning given the grade comes from an engineering and physical science course and spit back exactly what they wrote for E. That would have been easier.
Makes sense.
So meaning given a student is from the engineering and physical science department, he or she has a 50% chance of making a C or below.
You have mycosis, not mycosis, mycoplasma.
Mitosis.
Exactly.
Mycosis.
Meiosis.
Exactly.
Osmosis Jones.
Okay, are there any questions about this one?
Oh, God.
Okay, we've still got to do part 3, which says, which of the conditional probabilities found in number 2 tells you whether this college's engineering physical science students tend to earn lower grades than students in liberal arts and social sciences. Explain your rationale. Yes, dear.
E of L.
Why?
Because it shows the percent of engineering and physical sciences students that score a C or below in comparison to the other subjects.
You can help with that. As first percent of the student.
But then we would also have to find that same number, but instead of E, it would be the grades from the liberal arts to compare them on.
Yeah, so like what he's saying is showing both liberal arts and health and human sciences. So we would still need to do 2268 over the 3656 kind of thing.
Is this test going to be Monday?
This test is going to be Monday?
Is it?
Did I say that?
No.
I haven't said anything about when the test was.
Hopefully no time
Yes,
soon.
that's what she says.
I mean-
Again, after.
I mean, we're not that far from the end. This is true. It's not supposed to be a slow chapter. This is true. Monday makes sense, but more than likely it's Tuesday. I don't know how you knew that.
Learn something Monday and take it Friday.
Well, yeah.
We can't raise our grade.
You took a AP Math and a pre-AP Pre-Cal, and you're surprised? You did this to yourself.
Yeah, come on, dude, what are you doing? No.
I took algebra 2 last year.
Okay, so
I did too.
there are some more rules we can learn about that you don't actually need to memorize. So they're saying, if we were to rearrange this formula, and we could solve that to find the intersection. So if we knew the probability of A times the probability of B given A, we would know the probability of the intersection between the two. And again, what does this mean? Read what it means for me, Mackenzie. What does this mean?
What does this mean?
I covered up.
The rearranged formulas say that if we take the probability of an event times the conditional probability of some other event happening, given that the first event happened, that is equal to the probability of both events happening. These rearranged formulas are very beneficial when we make a flow chart called a tree diagram.
Okay, so again, I don't actually memorize those formulas, but I do love me a tree diagram. Read more about the tree diagram.
The tree diagram displays the sample states for a chance process that involves a sequence of outcomes.
Okay, so a tree diagram is literally just supposed to help us out and list out all our options. It's one way to just view all the options at once. And it's a little more, I don't know, user-friendly than a Venn diagram, I think. Okay, so let's make us a tree diagram. Read the exercise. Can you, please?
In this great, Roger
Federer. Yeah.
made 63% of his first serves in the 2011 season. When Federer made his first serve, he won 78% of the points. When Federer missed his first serve, he had to serve and had to serve again. He won only 57% of the points. Make a tree diagram to illustrate this exercise and answer the questions that follow.
Okay, so we're dealing with Federer, and we know that
He makes his first serve and he hits it, or he makes his first serve and he misses.
he made 63%, which means, so these are the serves made. First serves made.
My mind is kind of more like tree.
So,
Good branches.
It's gonna be really? You've never done a tree diagram? We do them all the time in discrete. Okay, so there's a percentage of serves he doesn't make, which is gonna be 20%, 27%. So it'd be serves not made.
Wouldn't it be 37?
No,
No.
63 plus 27 is not 100.
it is. 7 plus 3 is
Right,
10.
right.
Carry 1,
Get
6,
it right
7,
now.
8, 9.
It is
He wins.
37.
He wins. You win. You can have a point. If that makes you feel better, since I can't subtract today.
No, I don't
Okay.
want a point for correcting it.
No, you should.
Correct.
No, I appreciate that. You can have a point because I appreciate it.
What's the top one say?
First serve made. First serve is made. Whereas the 37 branch, the .37 branch, is the misses. And then we know from there we still have more branches to add. Okay, so when he makes his first serve, he won 78% of the points. So which means if he misses his first serve, no, his first serve was made, but lost points would be
22?
yes.
In fact, an anagram for mother-in-law is woman Hitler.
That's super useful, let me tell you.
You can anagram Britney Spears to say Presbyterian.
Really?
Now, it says when he misses his first serve and had to serve again, he only scored 57% of the points. So .57, he won points.
His life is hard.
Well, and he's really got good percentages.
No, it sounds really good.
Okay, so if he had missed it, he got 57% of the points, which means if he missed it, 43% of the time he lost points. Okay, so we've made a tree diagram, and the tree diagram seems great and all. But now we have to answer these questions. So the first one says, find the probability that Federer makes the first serve and wins the point.
So we can multiply that.
That would make sense, wouldn't it? So if we're looking out that branch,
So first serve, and this is .63, and wins the point, then .78. So it's
Yeah.
3 times .78.
it is, and that's one thing I need to say that it didn't specify above, so that's why I hesitated. Okay, so we've already discussed this, but if two events are independent, then we literally, to find out the probability, we just multiply. And these two events are independent, like, just because, I mean, I understand there is like a correlation and a higher percentage, but it's not like I'm a girl and I have pierced ears kind of a thing. I don't know, I didn't explain that well. We've already been over independent these things are, so we do actually get to multiply. So it is .63 times .78, but I'm literally just looking at my branch. I knew he made the first serve, I knew he won points, so it's .63 times .78, and I get, I'm going to do .49. So then the probability that he misses the first serve and loses the point. So if he misses the first serve, that happens 37% of the time. And he loses the point, that's .43. So when I multiply those things together, I get, so maybe, you didn't actually do it?
Is it
I don't know.
must be better?
What?
Did you
Is it-
calculate it?
No, he didn't. I didn't realize that yet.
Is that it? Maybe put one.
It's-
Did you make
It'll
it?
be 50, it'll be 159.
Dang it.
159, so .16.
Dang it. Of course.
Okay, so
Is that like a-
that's really good that the odds of him losing a point if he missed the first serve is only 16%, whereas he makes the serve and wins the point, it's almost 50%. That's really good. What do you notice about the sum of makes the first serve and wins the point, and probability of makes the first serve and loses the point?
It makes about 65.
So if we add the .49 plus the .16, we get about .65, which is about 65%. So what is interesting? What were we supposed to notice?
It's points even.
35% left or something.
Okay, 35% left, but we can already accommodate for that. It means he made the first serve, lost points, or he missed the first serve and won points.
So the middle is 35%.
So what do all the totals add up to? What do the conditional probabilities of each branch add up to? So we've already done this branch. The 0.63 times the 0.68, we got the 0.49. So working out this whole top branch, we've already got the 0.49. We've already worked out first serve missed and loses the point, and it was 0.16. So now they're literally asking us to work out in the middle two, which you're understanding because these two added to 65, the middle two need to add to 35.
Those would be perfect squares of their percentages.
They are, and that is curious.
That's quite-
So I need to know 0.37 times 0.57.
That one was 0.25. Probably not. Probably not.
What was it?
0.21 and 0.13.
Dang, I guess-
Okay, but again, they did add up. Ooh, that adds up to 34. So there was some rounding error.
Well, we rounded the 0.16 and rounded the 0.49.
Yes, because we rounded one of those. Oh, the 1-3, did it round up or did the 2-1 round up?
3 rounds up.
Okay, so it was 1-4. Okay. Because once you start rounding, you're like, I'm going to make this add to 100%. I'm going to make this happen. So now we really do have the 35 plus the 65, which adds up to 100. And so what do all the totals add up to? We add it to 100%. And what does the conditional probabilities of each branch add up to? We can, again, all the totals added up to. Yeah, they are all supposed to. I mean, everything's supposed to add up to 100%. That's kind of the point of percentages. Okay, so it wants us to go in reverse. So it wants us to find the probability that Federer wins the point.
Would it be the probability of both the 1 points thing?
Yeah. So why don't we just look at the 1 point? We know for sure he won points. So he may have made the first serve, so that would be the 0.49. We know for sure he won points. It may have been first serve missed, so add the 0.21. And we add those together, we get
0.6.
0.7.
0.7.
So 70% of the time he wins points. That's literally crazy. Okay, let's flip to the back.
Yeah, there's a bunch of Greek gods for this.
He really is really good.
I don't know, probably.
I feel like they would. It's a very classy man's sport. Okay, find the probability. I'm sure they do because they probably need.
I mean, yeah, but they've had
Yeah.
sports that weren't, back maybe with Khrushchev.
I'm sure they do. Okay, so then it says find the probability that Federer loses the point, and then it says two different ways. So yes,
5.
I can do the two losing branches. So say 0.16 plus 0.14, which is the 0.30. But it asks us to do two different ways. So what's another way I could find this?
Subtract the total of the 1 points from 100, or from 1.
So again, we could have just done the complement. We just found out it was 0.7% or 70% of the time he wins points. Then that automatically implied 30% of the time then he loses points. So what Kenzie did earlier with the complement would also work out here. 1 minus 0.7 gives us the 0.3 as well. Okay, part C, it says find the probability that Federer misses the first serve given he wins the point. So probability of missed given wins point. So what am I going to put in my denominator?
The 1 points.
And those added up to
The 70.
yes, it added up to 70. So we're literally adding up, looking at our tree. We know for sure he's on the 1 points branches. So we said 0.49 plus 0.21, and that's how we got 0.7. For sure we know he won points. So there's no need to have 100%. It's out of 70%. Okay, but now we're told specifically he missed. He missed the first serve. So what should I put in the numerator?
The 0.37.
That makes me sad.
The 0.63.
Oh, no, the 0.37 doesn't make me sad.
Yay.
Okay, I understand now. Sorry, I'm slow. But is he right? I mean, I see where he got 0.37 from.
Would it be assuming he missed the first serve?
So that's what it's saying. We know for sure he won points. So we assume he won points, which is how we got the 70% in the denominator. We know for sure he won. Probability of him winning the point is 70%. Given that he missed, so in the numerator we need to have the overlap of he missed and he won points. Is that what we have in the numerator right now? The overlap of missed and won points. The way before we had the overlap of male and has ears pierced.
So it would be 0.94?
0.94.
You said you put the overlap in it.
I don't know, I'm confused. I don't like
You know, just do the complement.
I like the table.
So,
I thought we've already calculated this. I thought we already calculated missed, wins points. We already multiplied those two numbers together.
you missed the first serve. You know, just do, the percentage of.
So we already had that. I'm looking at the missed 1 points per inch, and I already see 0.21. I did 0.37 times 0.57, and I got 0.21. So again, this formula you don't have to memorize, but what we're looking for is the probability of missed given he 1 points. You're going to have to put in the denominator the probability of him winning points. So everyone's cool with the 70%, because 70% of the time he wins points. But in the numerator, you have to put the probability of missed and 1 points. So not just probability of miss, not just the 0.37, but the miss and 1 point. So the 0.37 times 0.57, which we already calculated, which was the 0.21. Are there any questions about that now? It has to be the overlap. Before, when we were doing the boys and the ear piercing, it was the overlap of ear pierced and boys. So we need to do the overlap of miss serve and 1 point. Okay, last one and we're done. Find the probability that Federer makes the first serve given he loses the point.
So, the bottom would be number. Oh, the 30, I had to guess.
Well, the probability of him losing a point is 30% of the time, yeah.
And then 0.14 because he made the first serve but lost the point.
Thank you.
Okay, so,
So again, in the denominator, I have the total of him losing points, which we already calculated was 30%. But for the numerator, I need the overlap of, yes, I made my first serve, but I lost points, and that happens 14% of the time. Now, as Jackson would notice, because he's the one who actually owned this is not how we would probably leave our final answer since it's decimals. We would probably give them the percentage. But the fact that we got this far, surely we can type 0.14 over 0.30 into our calculator and go from there and get our actual percentage.
30, 47.
30, say it again.
30, 30, and 47.
Which one's 47? This one? No, that's 30, 30.
No, that's 30.
Yeah.
0.14 is.
yes.
Appreciate it.
No, yeah, because 21 divided by 7 is 3.
47.
Oh, I can't wait to go to work.
That actually makes more sense, because it would be
I love being a lifeguard,
7 over 15.
especially
That
when
actually makes sense.
my lungs are like in the worst shape they've ever been in. I get to go inhale fluorine gas for 3 hours straight.
You can always not work.
It's not an option.
You can always stop breathing.
You can always breathe.